All right, kiddos, now we're getting back to what we were meant to do before we went on this factoring hiatus, because remember how we solved by looking at a graph? We solved a quadratic by graphing. Now we're going to solve a quadratic by factoring. That's why we had to remember how to do all those factoring techniques. So once we factor it, what we have to know is how to apply the zero product property and how that helps us solve, and then go through the steps of factoring by solving, and then working backwards. Given roots, how do I write an equation, right? So those are our three goals. So let's get started on the first one here. The zero product property basically says that if you are multiplying two things together, if two factors are being multiplied together, all right, and their product is 0, then either one or both of those factors was 0. So think about this. If x times y equals 0, then either x had to be 0 or y had to be 0, or both of them had to be 0. Those are your only choices. So whenever we factor into the product of two binomials, it doesn't even really have to be two binomials. It can be a monomial and a binomial. But if their product is equal to 0, that means x plus 2 had to equal 0, or x minus 4 had to equal 0. So we set them equal to 0, and we solve each of them. So let me change my pen. Okay, so if x plus 2 times x minus 4 has to equal 0, then x plus 2 would have had to equal 0, or x minus 4 would have had to equal 0. So in this case, x would equal -2, x would equal 4. We just are solving. And then as a solution, like on the graph, it would have been -2, 0, and 4, 0. So these are nice because they've already factored them for us so that we could just practice the zero product property. All right, we'll do one more. X plus 3 times x minus 7 equals 0. So that means that x plus 3 had to equal 0, or x minus 7 has to equal 0. So x equals -3, or x equals 7. And so you would get the ordered pair -3, 0, and 7, 0. Okay? So we're going to write them in ordered pair form. All right? I want you to take a minute to answer the video question. It's on problem number 3, and then come back and see the worked out solution. All right? So if these two factors multiply together to equal 0, then 2x minus 5 had to equal 0, or 3x minus 9 had to equal 0. So now just solve for x. 2x equals 5, x equals 5 halves, so that's 5 halves, comma 0. Well, we can't read that. What are we going to do? So I'm just going to sneak it up here because I'm running out of room. So it's the ordered pair 5 halves, comma 0. This one, 3x has to equal 9, x has to equal 3. So it's 3, comma 0. These are your two solutions. This is a solution, and this is a solution. Quadratics generally have two solutions unless the vertex is on the x-axis, and then you get what's called a double root. So now we can solve by factoring. First, we're going to factor everything, and then we're going to take each of those factors and set it equal to 0 and solve. So just like we did with factoring before, we're going to find A and B and C. So we're going to find two numbers that multiply to 2, multiply to equal 2, that's A times C, and add to equal 3, that's B, all right? So we're going to have 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. So we have x squared plus, now we rewrite 3x as 2x plus 1x plus 2. And we group. And I factor out an x and I get x plus 2. Then I factor out a 1 and I get x plus 2. So notice how I have this matching, remember here and here. So now I get x plus 1 times x plus 2 equals 0. So now set each of those factors equal to 0 and solve. So that meant x plus 1 could equal 0, or x plus 2 could equal 0. So we get x is equal to -1, x is equal to -2. So our roots had to be -1, 0 and -2, 0. Okay. The next one is another one. We're going to have to rewrite it in standard form. We got to get it set equal to 0 in order for the zero product property to work. So we have 3x we have 3x squared plus 5x minus 2. Now that equals 0. So A is 3, B is 5, C is -2. So we're looking for two numbers that multiply to equal -6, or add to equal, and add to equal 5. All right? So let's try 1 and 6. If I add those together, I get 7, but if I do -1 and 6, -1 times 6 is -6, and -1 plus 6 is 5. So now I'm going to rewrite it as 3x squared minus 1x plus 6x minus 2 equals 0. And now I'm going to group. I'm going to pull out an x, or a 1x if you like to, and that gives me 3x minus 1. And I'm going to pull out a 2, and that gives me 3x minus 1. So now I have 3x minus 1 and x plus 2 equals 0. Now I set each of those equal to 0. So that says 3x minus 1 equals 0, or x plus 2 equals 0. So this says 3x equals 1, x equals 1/3. Be careful of that. So you get 1/3 comma 0, and then x equals -2. So you would get -2 comma 0. Subtract 2 from both sides. Okay? All right, we're getting there. Now we're going to work backwards, okay? We're going to write an equation from its roots. So let's look back, okay? Here are the roots. We start with the roots as ordered pairs. We make note of what the x's equal. Then we're going to have to move our what x equals back over to the left. Rewrite it as the product of those two factors set equal to 0. And then we're going to multiply it out, all right? So here we go. We have -2 comma 0 is a root, and 4 comma 0 is a root. So that means when we got towards the end of our solving, we would have had x equals -2, all right? If we move the 2 back over this way, we would have x plus 2 equals 0. If we would move the 4 back over, we're going to have x minus 4 equals 0. Remember, we're working backwards, okay? So all I did was move the constants back to the left, all right? Now, I just rewrite the expression as the product of those two factors, all right? Because from here, we could say x plus 2 equals 0 and x minus 4 equals 0. Now I'm just going to multiply them together, and I get x squared minus minus 4x plus 2x minus 8 equals 0, and x squared minus 2x minus 8 equals 0. And that was our equation from which we got these two roots. Okay, let's try one more. This one has a fraction in it, okay? But don't be freaked out about it because it's very easy to get rid of, right? So we have the two solutions, a half zero and 4 0. Okay, so that means x had to equal a half and x had to equal 4. Now move them back over and I get x minus a half equals 0 and x minus 4 equals 0. Now instead of doing fractions, let's take this one and multiply everything by 2. So this says that 2x minus 1 equals 0. And then keep this one the same. X minus 4 equals 0. Now pull them together. 2x minus 1 times x minus 4 equals 0. Now multiply them together. 2x squared minus 8x minus 1x plus 4 equals 0. Combine these. 2x squared minus 9x plus 4 equals 0. And we just wrote the equation. Do not be alarmed about this step. All we did was clear our fraction by multiplying every term on this equation by 2. 2 times x is 2x. 2 times negative a half is negative 1. 2 times 0 is 0. Okay? All right. I'm going to stop here, and then we'll do applications in the second video. Thanks for listening.